Am I live? It's really innovative how, it's a great way to tune people out by having it just on the headsets. But anyway, good morning, everyone, and welcome to What Does AI Mean for IoT Development? I'm your host, Alan Proithis. Just for our sake of order today, what we're going to be doing is all the panelists will be doing a short self-introduction, and then we'll jump into some questions. So to start it out again, I'm Alan Proithis. I am the CEO of Capstone Partners, a strategic advisory that accelerates connected business. But in my lurid past includes being president North America for Sigfox, where I built a network covering 70 million people, and most recently was CEO of a private 5G company, which I sold, which was doing high data IoT applications. So everything from high data to low data is all in the bag. So you want to start us off?
Yeah, thank you, Alan, and hi, everyone. My name is Andreas. I'm with Imagimob, part of Infineon since a little bit less than 2 years now. And whereas Infineon is well established as a big hardware company, we're focusing solely on machine learning and especially for the edge. So we want to enable users to build their own models, and we also give guidances on build some predefined models and help users to get up and running in machine learning.
Yeah, thank you. Thank you very much for having me here and for the invitation. So I'm Jens Binder, Managing Director from ithinx. Background control engineering. Had a very thrilled start in my career on the Formula One engine development, but now I'm since 10, 15 years in IoT development, strategic side. I'm leading the company. We are focusing on edge development, edge sensors, edge gateways. This is where we are, where our focus is, and I'm happy to be here.
Great. Pete Bernard, CEO of the Edge AI Foundation. We're the world's largest community of Edge AI developers, technology providers, and academia. And we have a number of partners here today, and I'm really excited about just the whole topic of Edge AI and what's happening in this space. So it's cool.
I've heard rumors this AI stuff might result in something, Pete. So, And for full disclosure, if Jens looks relaxed, he just came back from holiday, so he's really ready to. Yeah, he's the smartest one here, right? So let's start out, Andreas. So Andreas, we hear about, one of the things I talk about is AI and IoT is like chocolate and peanut butter, in that the whole point of IoT through its history is getting data to make better decisions. AI helps accelerate that process in my mind. So how do you view upcoming IoT developments, just in terms of start out by like edge versus cloud and the intersection with AI?
Yeah, fair enough. Valid point. And I think I have to say that as of now, or like how I see it now, because technologies, what we are talking about today, might be obsolete in 1 year or 2 years. But as of now, there's no hard cut really. So I think both are valid. Where you want to have breathing, respiration detection, where you want to have a heartbeat detection, I believe edge applications are very, very important because you want to be fast, you want to act fast. But on the other hand, when you want to have data analysis going longer, eventually even, and that's something where we are looking, like eventually doing something over the air, then the cloud is essential as well. So I think the edge is good for real-time feedback, and the cloud is good for perspective, and IoT development needs both.
Great, thank you. So Jens, let me ask you, because you come from a industrial product development background, and it's funny because you always hear concerns about ChatGPT helping all the kids cheat on their homework, but the real value is actually really in things most people don't ever see, like industrial development. So help me understand, how does all this edge stuff impact the design and implementation of what you're doing?
Yeah, thank you, Alan. Good question. So the development of the edge is completely changed. If we look, we had a 10 years background in the opening speech, how IoT is changing. So for us, in the former days, we tried everything to bring the data to the cloud, which is very simple. Everything was in that. On the edge side, it was a more or less communication environment. So now, it's like an organization, reorganization of it. So it's a more hybrid stuff of it. So we have let's say, a lighter way AI bringing to the edge. Makes sense on that stage, but on the other hand side, it's more complex from the development side. So we have, on one hand side, we have calculations in the cloud. On the other hand side, we have calculations on the edge. We need lightweight AI modules running on a semiconductor side. And the complexity on the edge development, it's much higher due to what we find on, we need calculation side, we need integration of AI modules. Antenna design is important. So yeah, that's a big change on AI. But it makes sense because security, privacy, and all these kind of things, it's much more related to edge. Yeah.
Sure. That's for sure. You know, it's interesting because all the hypercloud models, if you think about it traditionally, it's charging you for in and out, right? It's assuming that all your data is always going to go to the cloud. And it's interesting because my last company actually announced a deal with Dell and Intel to be their private cellular partner on the edge last fall, simply because, okay, we want to do all this stuff on the edge, but how do we actually get all the data to do something on the edge? So Pete, you know, how do you think about, you know, how we develop and deploy solutions? Because this is really it's a different model from a technology standpoint, but it's also a different model from an economic standpoint as well.
So a little anecdote on your comment about cloud. So I worked at Microsoft for 18 years. I got all my Microsoft stocks. I'm a big fan. But the interesting thing about their model is, you know, they charge you to get on the train and then they charge you to get off the train, which is really interesting. So they get you both ways. But you were talking about kind of the design and deployment of these kind of solutions and how things have changed. A lot of it, you know, you mentioned about complexity. There is more complexity now, and that's always been, I think, in the IoT space, one of those big points of friction, right? There's the CTO of the Fortune 500 company that has a problem, you know, Domino's Pizza or whatever, and they know they have a problem, but it's very complicated to sort of put together a solution and all the parts to deploy that. And I think with AI, it's more powerful, but you add in the issue of data and data quality. And so I think that's one of the big things people are realizing is, you know, the data set that's training the model, you know, how clean is your data? And, you know, unfortunately, a lot of folks don't have clean data, and the old garbage in, garbage out issue arises, right? So I think that's one of the big differences now with IoT development is you have to really understand the provenance of your data and the cleanliness of the data and how you're training the models. Otherwise, you may get really disappointed. So.
Well, to that point, I still think about, and it's one of the reasons edge can make a difference, because I still think about in some manufacturing environments, they still have a polling methodology, right? It's always polling, hey, you okay, machine? You okay, machine? And so 99% of the data is completely useless. It's really the exceptions is really what you need to work on. And as you move that compute, and Pete, I don't want to steal your phrase you told me last night of full attribution. He said, instead of taking the data to the AI, take the AI to the data. And I think that was actually a great perspective on that. So the term AI is, let's just be charitable and say it's very loosely used for most people. The big joke up until the last 2 years, a friend of mine in Silicon Valley used to say is, do you know the difference between machine learning and AI, by the way, up until recently? Machine learning was generally written in Python, and AI was generally written in PowerPoint. And it's really only been the last 2 years that's really changed in a market level. And so, when you think about something that is smart, and is processed on the edge, how much of that do you think is happening on the sensor itself? How much of that is happening on sort of larger compute that is located on premise? And maybe we could just go down the line and answer that.
I think it really much depends on the use case. But if you consider the devices getting smarter and smarter, sorry, I lost my track of thought. Maybe you can continue. I lost my track of thought.
Yeah. But I would answer more or less the same. So for me, it's a kind of question is the use case itself. So this will relate to where is more calculation and where's more benefit on the cloud side or on the edge side. Yeah, depends on the use case, on the vertical where you implement the AI.
I was going to say, I think there's always a gravitational pull toward the edge, Like, so there's a gravity there. And, everyone starts their project on the cloud to try to sort of figure out how to do this, get their models set up. And then it migrates to some maybe heavier edge component. And then someone says, that's expensive. Can we make it cheaper? And you know how it goes. So there's a gravity there. And so I think over time, as the edges become, and even we just had a panel on the farthest edge talking about spiking neural networks and like sensor edge, as those become more capable, there's just going to be a migration of data and processing closer and closer to where the data is created. Ideally, you want to be running your processing where the data is created. That's the ideal from a latency, privacy, cost, impact perspective. So I think of it more of a gravitational pull over time, and some people are getting there faster than others, I guess.
Yeah,
Please.
it came back now.
Cut us straight.
Yeah, yeah. Now that Pete mentioned the panel before, for those who attended the panel before, there was discussions about the downtime of machines as well as heartbeat detection and making the loop to where the device is getting really, really smart and really from smart to really intelligent. I believe when you not sense for the sense of sensing, but sense for the sense of working with this data, you can improve those or like cut down those downtimes and improve the heartbeat detection from that standpoint.
Let's talk about security for a second. Security just seems to be this nebulous thing. And I used to joke in the IoT space, everybody asks you about security, but nobody wants to pay for it until they get hacked. And, we've seen major telcos get hacked in the past year. We've seen a lot of everyone get hacked at a lot of levels. So let's talk about for a second, maybe Pete, you can start us off, just how should we think about security when we start implementing new models? It typically is stressful for IT people because new models mean new vulnerabilities is the first thing they're going to think of. So how do we think about this new model, which I think is inevitable, but how do we think about it in the concept of cybersecurity?
Yeah, well, it turns out that, especially like in the industrial space, the models themselves are quite valuable IP. I mean, we go back to the data we're talking about. So if I'm a lumber milling company and I've collected some really valuable data about, fault detections on timber, and I've trained models on that, that's a lot of really valuable IP. So one of the things we're seeing is there's a lot more protections put around that IP when it's in motion, when it's in transit and being updated from the cloud, and when it's at rest on the device. So we're seeing a lot of the traditional kind of trust zone encryption, decryption techniques being applied to the models themselves and the data, which I think is a good first step. In Europe, there's the cybersecurity and other kind of best practices things. I was joking in the last panel. In the U.S., we have no regulations, so it's not a problem. But it's really about best practices of keeping that data and the data sets, I think, secure and encrypted is kind of the step one.
Yeah. How do you think about that, Jens? Because you're dealing with all kinds of industrial data.
Yeah, we are dealing the same. So on one hand side, I'm completely with you. So the answer is for sure valid. The other one is, so for sure we have the IP data more stored on the edge and handled on the edge, and this is a big advantage. Another one is the autarky in the systems itself. So we don't need the cloud to run a system if it's hacked. This is a big advantage where we see a benefit of AI in security apart from where the data are stored. Yeah. So we have a possibility if there's something hacked on a cloud, because this will basically the first entry gate. We are safe on the edge side if and can stop it.
Interesting.
Yeah, totally agree with my predecessors. Bringing the computation to the edge just adds another layer of another wall, being completely secluded from where the computing happens.
All right, so I'm a company who's been reading about all this. It's very difficult because it's a bit of the Wild West. By the way, I live on the East Coast of the U.S., so I'm not a cowboy. But people talk about the Wild West, and any new technology, it takes time to figure out what's the right mix of tools, what the right mix of development and deployments are and management. But your customer, if you're a CEO right now or a product leader, you can't go to your board or CEO and say, this AI stuff's pretty crazy right now. Let me come back to it in a year or two when it settles down. You know, the competitive advantage just from the education you'll learn, you'll fall so far behind. So let's talk about how do you get started? What kind of project, when you think about the development and the deployment and maintenance, because, you know, after you get it out there, people, it's amazing how many people forget they got to maintain something after they deploy it. But what do you think is something that's lower risk, you know, higher return to sort of give management confidence to let you develop more things? Jens, why don't you start?
Yeah, let's say we are always running about the customer journey, so it makes always sense to talk about what's the benefit for our customers. So if you look at the design, see, maintenance is one part, so it's everything is proactive in the system. So the edge is much more proactive and says there's a point, there's a hack, there's something in my systems running. The other hand side is where are the data protected on that side. This is also normally now something we talked about before, which is important for the customer, and the rest is you have with a redundancy of latency, you have the possibility to run much more, let's say, not real time, but more real-time operations than ever in the system.
Yeah. What would you say, Pete? Where do you get started?
Well, yeah.
I would say, you know, like one of the things, we get a lot of Fortune 500 companies that coming into the foundation to sort of understand who's doing what and what is Edge AI and how it works. And there's a lot of, you know, I don't know if you know the term brownfield deployments out there. So they already have deployed things and they want to add AI capabilities to it. So that's always a good place to start. We just had on the panel before, you know, with a lot of low power, battery powered things, you can do almost like peel and stick anomaly detection. You know, where you can go into a factory or something and add in, you know, always on sensors to understand telemetry and predictive maintenance. Things like that are like, they're not in the critical path. Like you wouldn't, you know, shut down your manufacturing line if something didn't go right, but it adds more kind of AI smarts to brownfield deployments. And that's usually a good place to kind of get started.
From a little bit from another direction, what I've seen and read is a little bit of evaluation and testing fatigue because the solutions we're having out there right now mostly are developed by developers for developers. So what I would see as an interesting train of thought is if you could get more hands in your team on the product before you bring it out there, so that it's more handy, it's more usable, hence easier to get in potentially.
The other part of this we're not going to dive into today, but is the cost basis. Because I have a son working at a major financial institution who runs product management for an AI team there, and he has to play traffic cop on the projects to come in. And one of the bigger questions, people don't understand that the compute is not cheap. And you need to actually understand what the ROI is for the application that you're asking to implement. And there has to be a business component to how you evaluate, how you prioritize these projects for a business outcome. And you know, I know there's a lot of engineers here, and not to throw out those dirty words about making money, but you know, if you don't make money, you don't get to keep doing it, and it's just that simple. So it's important to prioritize. I know we're getting closer to the end of our time here, so let's take a second and say you have a crystal ball. Okay, what will the market look like in the next 18 to 24 months in terms of deployments, in terms of adoption? And I would add, if you had $10 million of your own money, not by name a company necessarily, but what type of technology would you invest in today?
Personal.
Make it 10 million euros, it's more money.
Personal interest probably, and gut feeling. I have a favor for humanoids, so I would say humanoids is pretty interesting for me.
Given the 20, was it 20 or 25?
Let's say
So
18 to 24.
yeah, and coming from my holiday, so it's not easy to answer. But I would say to design a new thing for smart living for generations to come is a good answer to that. To put and invest it in projects who save that.
By the way, I was going to say the difference between ML and AI is about $1 billion of valuation. So people out there, you're going to get that. But I think the next few years, we're starting to see like kind of a mashup of sensor type AI models and language models, like generative and agentic AI making its way into the edge. And I think you're going to start to see like visual language models and other things where you're adding like language context to sensor data, and that's going to enable inanimate things to become a lot smarter or seem a lot smarter. They'll still be dumb. But I think that's going to be something we're going to see. I think you're going to be able to talk to a piece of equipment and it's going to tell you what's wrong with it and what its issues are, your car engine and things like that. I think that'll be interesting for people to wrap their heads around.
It's very interesting that you say that as an example, because one very early stage company I'm advising is doing just that with telecom infrastructure, where you can say, tell me how many sites or towers in this city have space for this kind of equipment at 100 feet. Gives you a report. How many have more than 17% rust? Boom. And the time saving of that is just amazing. You really can't do that without edge data at Edge AI. So we have about 1 minute left. Let me check and see if there's any questions from the audience. Everybody still alive? Breathing? Please.
This question is for Mr. P. So, which company are we investing money in tomorrow?
Yeah, I was just about to follow up.
Ooh, yes. I don't want to give any investment advice. That'll jam me. But I think what's really cool is the ultra low power edge, like companies that are providing semiconductors and kind of there's huge volume upside there, and they are breakthrough types of things. So I'm really keen on those companies that are doing ultra low power. Anything that mitigates the use of power in AI is a winner, and you can even probably go up the value chain there too. But power is one of the biggest stumbling blocks to the advancement of AI.
The other thing I would add to that is I think there's a big gap around deployment services. If you've ever tried to deploy either private networks or a large amount of sensors, this is coming from someone whose team deployed 10,000 sensors for the monitor garbage cans at Disney World. Let me tell you, it is probably the weakest link in the chain in many cases. Just the hands-on. So when people say, is AI going to take all the jobs? I always say, well, there's no more buggy whip makers, but people just didn't die along the road, right? They migrate to things that are needed. Please.
The one area I would invest in is companies selling small nuclear reactors to hyperscalers because they need them for their data centers. So.
And Microsoft was kind enough to restart 3 Mile Island 30 minutes from my house and buy all the power for the next 20 years. What could possibly go wrong? But no, it's a whole different generation of technology. So with that, that's, I believe, our time for today. So thank you for coming. Thank you, panelists. And I think we'll all be milling about here for a bit if you want to speak with us. Thanks.